right, let's talk about the materials that we need for this lab. Now, I know that you guys are at home and you are not in charge of getting groceries at your house. So, if you have hot chocolate, you got my email, your mom and dad or whoever, parent, guardian went out and got you a packet of hot chocolate, or you maybe have some already in your pantry. Super cool. If you don't, never fear. You can absolutely just get a cup of hot water and do the lab with us the same as we're doing right now. It just won't be quite as cool, but that's okay, you know. And if you can't have hot water, you don't have any hot water, just watch the videos. We're going to talk it out and it's going to be totally fine. Okay? No worries. So, we're going to talk through here just like you have it at home, okay? And like I said, if you don't stress. It's not a big deal. To do this, here at school, I need a hot plate, which is right here. I need some hot chocolate, which I have here. I need some water, okay? It's in my beaker, and I also kind of cheated and put hot water right here. I just wanted you guys to see this. I need an ice cube, which I have in my cup right here. I've got some ice cubes. I need a stirrer, so I have a spoon to stir my hot chocolate with. And then I need a cup. So I've got me a cup. I've got everything we need. We're going to go ahead and make our hot chocolate. So I put my hot water in my mug already. And I'm going to go ahead and put my chocolate in here and stir it up. While I'm doing this, and while you're doing this, I want you to pay really, really, really close attention to any types of heat transfers that might be happening right now, okay? Also, I want you to be super, super careful because however you're making your hot chocolate, your cup is going to be hot and your hot chocolate's going to be hot, okay? So be super duper careful. I'm going to throw possible other materials at you, and this is only if you want to. Who doesn't like a marshmallow in their hot chocolate? Some people don't, but I think they're kind of fun and puffy and tasty. So you can put marshmallows in your hot chocolate too. Okay, I'm opening up my chocolate and I'm going to dump it on in there and we'll stir it up and see what happens. Normally I would put my chocolate on the bottom, but I mixed it up for y'all so that it would make a easier video so I don't have to run around pouring my water, you know. So I'm stirring it pretty carefully. Here we go. We're going to start looking at our data now, okay? So my chocolate's getting stirred up. It smells delicious. I love me some hot chocolate. Now, our first question is, do you find any evidence of conduction right now with our cup of hot chocolate? Is there anywhere in here that you could see conduction happening? Now, I want you to think about it. Don't just put down what I'm saying right here because there's a bunch of different things, and I'm just going to tell you one. I want you to experience this at home, and any that you find that I didn't talk about, I want you to put them in there and you'll get more credit for them, okay? So the more evidence you have of conduction, the more credit you're going to get. The one that I'm going to tell you about is putting my hands directly on this cup of coffee right now. I'm sorry, the mug of hot chocolate, and it is hot. My hands are burning, so I'm not going to be able to hold it for very long. I'm in direct contact with this cup, and my hands are hot, okay? So that's the piece of evidence I'm going to give you. There are several more pieces of evidence for conduction happening right here. We already said conduction is the direct contact, okay? I want you to look at your cup of hot cocoa, or mine if you don't have any, and tell me what you think might be happening here to make conduction a thing. As I add the marshmallows in there, as I add the ice cubes in there, you can add to your conduction results, okay? Now, let's look at convection. Do you see any evidence of convection happening right here? Now, you might not see it here. It might be a little easier to see right here. Now, I don't know if you guys can see those bubbles. I need something dark behind there. Let's see. Can you see the bubbles that are floating up right there? So it's forming bubbles at the bottom, and they're going up to the top right here. Well, that is just starting to boil a little bit. It's not doing it yet, but it's starting to. That's convection. It's getting hot down at the bottom, and it's coming up to the top. If you boiled any water on the stove ever, you would see the same thing. So there's your evidence of convection is whenever we heated the water, those currents were in there. I know it's hard for you to see, but it was happening, okay? If you see any other evidence of conduction, you can write it down. Okay, or tell me about it in the assignment. Next, we have radiation. So, in your cup of hot chocolate, do you see or can you feel any evidence of radiation? So right now, I'm not touching my cup. My hands are just close to it, y'all see? And I can feel that heat. Even without touching it, I can feel the heat coming off of that cup. Kind of cool, right? Okay, so I'm gonna go ahead and get a marshmallow, and I'm gonna put it in here. I might get more than one, maybe a little handful. Okay, so as I put my marshmallows in here, something's gonna happen to those marshmallows. Kind of like that question where we had a person taking a hot bath. What type of heat transfer was that with a person in a hot bath? The same idea is happening to these marshmallows right here. I'm not going to tell you which one it is, but that's a type of heat transfer too, and that's one that you can write down for your lab for more credit for one type of those heat transformations, okay? So my marshmallows are starting to get really puffy right now, but this hot chocolate is still too hot for me to drink. I'm going to have to do something. Well, I have some ice right here, so I'm going to gently drop a couple ice cubes. Okay, I ended up more than a couple. Let me get rid of one of them. So, when you put ice cubes in your hot chocolate, how is the heat going to travel? Is the heat going to travel from the ice cube into the cup? Or is the heat going to travel from the hot chocolate itself into the ice cube? Well, it's going to travel from the heat itself into the ice cube. So my ice cubes are already almost gone. Apparently this was really hot. There's almost nothing left of them right there. Whenever heat's moving in something, this is a really good conversation for us to have. And there's a question about this below. Okay, whenever heat's moving, it always goes from the hot stuff into the cold stuff. And we've watched Brain Pops about it and everything else. It just has to do with how fast those particles are moving. So when you get something hot and something cold, the hot is going to move into the cold and it's going to move those particles faster, okay? Until they reach the same temperature. So if you guys have any questions about that, make sure you ask me, okay? Because that'll be on the test. And then conclusion, how did your hypothesis compare to what actually happened? So how many different types of energy transformations did you see happen if we made a cup of hot chocolate? If you said you thought we would see conduction and only conduction, well, put that in your conclusion. Was your hypothesis correct or incorrect? I just want you to type it out and let me know, okay? I hope you guys had fun. Once we are finished with all your questions below, you can go ahead and drink your hot chocolate. Remember, be careful. If it's as hot as mine, I don't want you to burn your little cheeks. But I hope you like it. Have a great day. Remember, the test is on Tuesday next week. Y'all are amazing.